Alright, this is 3.4 rectilinear motion, notes page 7. It's a continuation from the prior vertical motion example. So the next question is, what is the speed of the ball when it hits the ground? In the prior question we found out that at time of square root of 27 is when the position equals 0, or when the ball hits the ground. So we need to know the speed of the ball when it hits the ground. So basically what we need is, if we plug in time equals square root of 27 into the velocity equation, so v of root 27, that'll give us this answer. If you recall the velocity formula, I'll write it over here. The velocity formula was negative 32t. So the velocity at root 27 would be negative 32 times square root of 27. And that comes out on your calculator to equal negative 166.277. And that is a feet per second velocity. The question is asking for speed, however, and speed is simply the absolute value of velocity. So the speed is 166.277 feet per second when it hits the ground. Make sure you have the right sign. Make sure you have the right units of measure. And on word problems, it's nice to have a sentence answer. Okay, here's the next problem. A ball is thrown vertically upward from an initial height of 6 feet with an initial velocity of 20 feet per second. We want to write the equation of the motion of the ball, first of all. So if the initial height is 6 feet, that's going to be initial position, 6 feet. Initial velocity of 20 feet per second, that's initial velocity, v sub 0, and it's 20 feet per second, and it's going to be positive because initially we throw it vertically upward. So it's actually going to go straight upward. And if you think about it, it goes upward for a certain distance, and then it turns right around and starts coming back down vertically along the same path. And we'll be able to learn some things about its path, or its the height and the time it takes to be at different locations. First, write the equation of the motion of the ball using the same form that we did, that we showed on the last page. We got 1/2 times the acceleration. Since we're using feet per second, the acceleration is negative 32 feet per second squared times time squared, plus the initial velocity times t, so it's 20 times t, plus the initial height of 6. So that's the equation. We can clean it up. So we get s equals, that would be negative 16t squared plus 20t plus 6. So now here's some questions that would come out of this. How high will the ball go, and when will it reach the highest point? Okay, so again, like when I was talking about, if you throw the ball straight up, it goes straight up, and at some point it's going to stop and reverse its direction and come back down. So where it stops and reverses its direction, that is actually the highest point. Okay, so at that highest point, the velocity for that instant is equal to 0. So at the highest point, where it's going to turn around, the velocity comes to 0. So we need a velocity equation here. If we set the velocity equation equal to 0, we can see what time this occurs. So velocity is the rate of change of position. So we get negative 32t plus 20. The 6 goes away. I need to set that to 0. So let's see, I've got 32t equals 20. T equals 20 over 32. And that reduces to 5/8. 5/8 is 0.625. It's a terminating decimal. Either of those values will work. Okay. Keep in mind t. This is my time at the highest point. And what were we asked about this? How high will the ball go, and when will it reach the highest point? So we've got the when taken care of. It happens at time equals 5/8 seconds. How high the ball goes, we would have to put 5/8 of a second into the position function. So evaluate s of 5/8. So we'd have negative 16 times 5/8 squared plus 20 times 5/8 plus 6. So the position at 5/8 seconds, if you plug all that in, you get 12.25 feet. And that ends up being the height at 5/8 of a second, which is its highest point. 12.25 feet is the highest point. Okay. The next question asks us to find the speed of the ball when it hits the ground. So it's going to first go in the upward direction, stop and come back down, and eventually hit the ground. So it hits the ground when the height is at 0. So we'll say it hits the ground when s equals 0. So we'll use our original position function right there, set it equal to 0. So negative 16t squared plus 20t plus 6 has to equal 0. Let's see, I think this factors, I'm going to factor out a 2, actually a negative 2. That'll clean it up a little bit. It gives me 8t squared minus 10t minus 3 equals 0. And this might take some trial and error, but I think if we try 4t and 2t, I know I've got to have a 3 and a 1. So a 3 here would give me 12 and a 2. That looks like that's going to work. A 3 here gives me 6 and 4. That would work too. Actually, only one of these can be negative though, so I'm going to have to go with the 3 and the 4. Give me negative 12t, and then plus 2t. That generates the negative 10t in the center. Okay, so zero product property for this one, 4t plus 1 equals 0. That would be t equals negative 1/4. You cannot have negative time, so that is out. And this one would give me 2t minus 3 equals 0, or t equals 3/2. That's one that I want to work with. The time when the ball hits the ground is 1.5 seconds. Now I need to find the speed when that occurs. So I just need the velocity at 1.5 seconds. My velocity equation was negative 32 times the time plus 20. Alright, so I get, this is 16 times 3, so it's negative 48 plus 20. Negative 28 feet per second. The negative would indicate that it's moving down at 1.5 seconds. Actually, that's when it hits the ground, so it's moving down in its last possible chance to do so. And to answer the question, velocity is negative, indicating it's going down. Speed would be the absolute value of this. So basically, speed is 28 feet per second when it hits the ground. Okay.